Okay, so I wanted to take a minute to go through our trig identities and how we're transforming equations and some of this kind of truly difficult stuff that we're working on here. Okay, this is all information that is contained in 5.01 in our online curriculum. So we want to be able to use the different trig identities as we're working through these, and those are going to help us manipulate an expression, and we want to transform it so that it looks like what's on the other side. And this is hard because there's no actual math involved. What you're doing is you're simply manipulating and substituting in equivalent expressions for other expressions until both sides look exactly the same. So this is really abstract and can be very difficult to kind of wrap your head around because you're not getting x equals 5. You are simply manipulating an equation or an expression using equivalent trig identities in order to make it look a little different. Okay, and that's where we're going to talk about maybe some strategies or some different things to help you with that. The first thing you really need to know are the trig identities, and these are the ones that we're going to be using. First of all, you have your reciprocal identities. So each function, each trig function has a reciprocal. Sine and cosecant go together, and you need to know that one is the inverse of the other. Cosine and secant go together. Tangent and cotangent go together. These are very, very important to know so that you know which one is the inverse of the other. So if you have cosecant, that's really 1 over sine. If you have cosine, that's 1 over secant. You can really use those to manipulate things around. You also really need to know that tangent is sine over cosine and cotangent is cosine over sine. Those become really important in later on helping us solve things, but right now in manipulating these identities. And then come the Pythagorean identities, sine squared theta plus cosine squared theta equals 1, etc. Those are going to be really helpful in helping us manipulate these expressions. Let's jump into it. So I have got this expression here, cotangent of alpha times sine of alpha equals cosine of alpha. Often we use theta to designate angles, but alpha is also alpha and beta we use to designate angles as well. Okay, so this is just an alternate to theta, and it doesn't really mean anything in this expression. Okay, so I'm going to start with the fact that I know cotangent, back to my identities, and guys, I have these written out on a paper and I'm looking at them right now. I would strongly suggest that you do that as well with the identities. I don't expect you to memorize them, but you need to know how to use them, and you can't use them if you don't have them. So write them out and use those identities, okay? I know that cotangent is cosine of alpha over sine of alpha. That's one of my trig identities, okay? So that's the first sort of substitution I'm going to make. Now I'm only working on the left side. I'm going to ignore this right side for now. You won't even see me put anything on the other side of the equals because I have found that it's confusing for me to look at both sides. I'm used to looking at both sides of an equation to solve, and that's confusing in this situation. I'm just manipulating the left side, so I'm going to focus only on the left side. I'm going to leave the right side out of it for now. My goal is just to make the left side end up at cosine of alpha, okay? So I'm on my way here. Now I've got cosine over sine times sine. And I'm just going to put this over 1 to make it look nicer. Remember that when you're multiplying and you have something on the top that's the same as the bottom, they actually cancel each other out, which leaves me with cosine of alpha over 1, which is cosine of alpha, which, hey, guess what, equals cosine of alpha. Okay, so that one actually wasn't too bad. I simply substituted in for cotangent what it's equivalent to, which is cosine over sine. I multiplied and I simplified. Okay, let's try another one. It's going to get a little harder from here. So I'm looking at 1 plus sine of theta times 1 minus sine of theta equals cosine squared of theta. So I'm going to work on the left-hand side and I'm going to try to get it to equal cosine squared. Okay, now I don't have any identities for 1 plus sine. I have identities for 1 plus sine squared, but I don't have anything for 1 plus sine. So I'm looking at this and going, I'm seeing two parentheses. I probably need to multiply those, okay? And I can see that this is difference of perfect squares. So I'm going to multiply those out to put them back together. which means that I have 1 minus sine squared of theta. Now, one thing I want you to note is when you are squaring things, you're not squaring theta, you're squaring the trig function. You're squaring sine, cosine, tangent, okay? You are never ever squaring the theta on this. So let's keep going. I have an identity that's similar to the 1 minus sine squared. I have an identity that tells me that sine squared of theta, my pen is not writing very well today, sorry about that, plus the cosine squared of theta is equal to 1. Now that looks similar because let's say I subtracted sine theta from both sides, I would have 1 minus sine squared of theta. Look at that. That looks like what I have up here, and that's equal to, you guessed it, cosine squared of theta, which is what I was trying to get to from the beginning. So sometimes we have to manipulate our identities a little bit to make them work. So because my identity is sine squared theta plus cosine squared theta equals 1, I can then subtract either sine squared or cosine squared and get the other one by itself. So I'm kind of manipulating an identity within an identity. And you're welcome to do that at any time, especially for some of those Pythagorean identities where you may need to have like tangent squared equals instead of secant squared. So you can subtract, okay? Moving on to another one. This one is very similar to the last one. I can see that I have difference of perfect squares, but guys, I'm trying to get 1. So I'm trying to get rid of my identities so that I just have 1. So I'm going to need some stuff to cancel out here. So first step, I'm going to multiply these out, and I'm going to get secant squared minus tangent squared, okay? I know that these are different perfect squares. I can go ahead and FOIL them too if I want to, if I can even draw my lines to the right spot and FOIL that out, but I don't really need to. I know this is difference of perfect squares. I'm just going to square them both, make my sign minus, okay? Now, let me see if I have an identity for this. I have an identity that is 1 plus tangent squared theta is equal to secant squared theta. So since I know that this is equal to secant squared, I think I'm going to substitute it in. I'm going to have 1 plus tangent squared of theta minus tangent squared of theta. Hopefully I can make this equal to the 1 that I'm trying to get. I know that when I have one value minus itself, they cancel. So tangent squared theta minus tangent squared theta leaves me with 1, which is what I wanted to get from the beginning. So that one took a little bit of thinking. I didn't really have to do much manipulating, but I had to figure out what identity would work. And that's all started with multiplying out those parentheses to get my squareds and then simplifying from there, okay? So it's kind of thinking about the process and figuring out like maybe how I want to get to my end result. I know that if I'm trying to get to a 1, it means that stuff is canceling out. I'm probably going to need to multiply or divide to get things to cancel. That kind of leads me to my process that I'm taking, okay? And I will be completely honest with you, I've been doing this for a long time. When I first started out, when I was in high school doing these, it was not this easy. There's some trial and error involved. And maybe you get going on some of these and you just keep getting expressions and more expressions that are more complicated and they're not getting where you need to be. It's okay to start over. It's okay to go back and try a different identity. It's okay to say, help, I'm not sure where to go from here. Okay. So don't feel like you have to have this mastered. These trig identities are a really tough concept. And it takes a while to be able to figure out where you want to go with them to manipulate stuff around. Okay. Now this one is a toughie because I'm trying to get to cosecant and secant. And to be honest, I'm not really sure how I want to do that. Okay. So what I'm going to start with is I'm adding 2 fractions. Whenever I add 2 fractions, again, I want to try to simplify stuff. I need a common denominator. So I'm going to start there with that. I'm going to get this into a common denominator, which is going to be cosine theta sine theta. I'm just going to multiply the two, okay? If this were 5 and 7, I'd multiply them to get 35. Most of the time when we're looking for a common denominator, we multiply the two pieces together, which means that this first fraction, I'm going to need to multiply the numerator by whatever I multiply the denominator. In this case, sine theta, which gives me sine squared theta. On the second fraction, I multiplied the denominator by cosine. So I'm going to do that on the top as well, and I get cosine squared. Okay, I just made this look a little more complicated, didn't I? That's okay. Sometimes we have to complicate and muddy things up in order to be able to simplify it and make it easier in the long run, or get it taken care of in the long run. So now that I have a common denominator, I'm going to put these together into one fraction. And I get sine squared theta plus cosine squared theta. Okay, that looks a little simpler. And I know that I have an identity that uses sine squared plus cosine squared. Looking at my identities, sine squared plus cosine squared is 1. Ooh, that just simplified things a lot, didn't it? Because now I've got some interesting fractions. Let's say I divide these up into 1 over cosine times 1 over sine. Mathematically, I'm allowed to do that. Okay, 1 over 35 is the same thing as 1 over 5 times 1 over 7. I can break that apart. And now looking at my identities, I've got some reciprocals. 1 over cosine is secant. Get my theta here. And 1 over sine is cosecant. And look, I have what I wanted to get to, okay? Yes, they're in a different order. I'll just rearrange them. It doesn't really matter. And I will get cosecant theta times secant theta. So that one was kind of complicated to figure out and get started with. And I will tell you, I looked at this one for a couple minutes and thought, should I try to do something with a 1 over cosine, 1 over sine, because I know those are cosecant and secant. Then I'm not really sure where that gets me and how to manipulate the other stuff. And then I thought, well, they're fractions. Why don't I try adding them together and simplifying the fraction? Maybe that gets me somewhere. So I started with that step. And then all of a sudden I see, oh yeah, here's an identity I can use. I can start simplifying from there. Now I'm getting to where I want. So sometimes it takes just like looking at it a little bit and where do I want to get to? What identities do I have that include sine and cosine? Or maybe I don't have an identity, so I'm just going to try some math stuff like combining fractions and go from there, okay? So I hope this has been kind of helpful for you to give you examples. There are a million of these trig identities that can be done. And honestly, it just takes practice. You just need to practice doing it over and over and over and thinking through the process, using the trig identities and trying to use logical thinking and reasoning to work your way through it. Okay. I don't have any like fast tips or tricks or anything. It just takes practice. So get some practice problems. If you need some, I can happily give you some and really just work on using those trig identities, manipulating them, figuring out how to reason through and get to your end goal. Okay. As always, if you have any questions, let me know. I'm happy to help. Otherwise, take care and stay safe.